In the example, it says an equation for the perimeter y of an equilateral triangle with side lengths x is y equals 3x. Does the equation y equals 3x represent a linear function? Complete the table and graph the equation. In the table, you can see that we start off at 0, 0, and then our x values are increasing by 1, and our y values are increasing by 3. It says the graph is a straight line, so the equation y equals 3x represents a linear function. As you can see in the graph, they have taken the points from the table and graphed the straight line. So in problem number 1, it says, in the example problem, what is the relationship between the perimeter and the side lengths of an equilateral triangle? So what do you notice about the side lengths and the equilateral triangle? You should notice that the perimeter is 3 times greater than the side lengths. Question number 2. What is the rate of change of the function? What does it represent? The rate of change is 3. Because in the equation, our general equation is y equals mx plus b, m being the rate of change. In our equation, y equals 3x, 3 is in the m's position. And so our rate of change is 3. The rate of change represents how many times greater the perimeter is. It represents how many times greater? Question number 3. The equation y equals 3x is in the form y equals mx. Jesse says the equation of the form y equals mx has no rate of change. Is Jesse correct? Jesse is incorrect. Because in the equation y equals mx, m is the rate of change. And so it does have a rate of change. It has a rate of change of 3. But it is, however, missing a y-intercept, because the y-intercept would be the plus b at the end, which it does not have. Problem number 4. Tell whether each equation is a linear function, then graph each equation on the same coordinate grid. Describe the results. So the first one, letter A, is nonlinear because it has an exponent. Which tells us that it is not a constant rate of change. The second equation is linear because it is in the form y equals mx plus b with a constant rate of change. I will come back to graphing problem number 4 at the end of this video. Problem number 5, it says write an equation that is a linear function. Then write an equation that is not a linear function. Justify your answers. My equation is going to start off with y equals, as it always does, y equals, I'm going to put 3x plus 7. That is linear because it is in the form y equals mx plus b. My nonlinear equation is going to be y equals 2x to the third power because it has an exponent which tells us the rate of change is not constant. Problem number 6. The weekly salary of a store manager includes a $30 bonus plus the number of hours the manager works multiplied by the manager's earnings per hour. Is the situation defined by a linear function? Write and graph an equation to check your prediction. So, if we start solving this problem, our equation would always start off with y equals. It doesn't tell us how much he makes, so we can just go with any estimate. I'm going to go with a simple $10 an hour. So I'm going to say he makes $10 per hour. In that instance, in that example, it would be 10x, because 10 is my rate of change, $10 per hour, plus his $30 bonus. This equation is linear because it is in the form y equals mx plus b. If we chose to solve this equation, I would set up a table of values. And I'm going to use the numbers 1, 2, and 3. So if he worked 1 hour, we would multiply 10 times 1 and get 10. 10 plus 30 is 40. He would get $40. If he worked 2 hours, he would get 10 times 2, which is 20, plus 30, which is $50. And if he worked 3 hours, we would do 10 times 3, which is 30, plus 30, which is 60. We can then graph the equation, and we'd start at $30, 0 and 30. We'd start at 1 and 40, 2 and 50, 3 and 60. As you can tell, this is making a linear function. Now I'm going to go back up to the top problem in number 4 and graph those equations because I didn't do it earlier. I have to make a table of values. So I'm going to start with x. My equation goes in the middle, and y goes on the outside. So I'm going to use the numbers 1, 2, and 3. So in the middle, I'm going to do 2 times 1 squared. 1 squared is 1 times 1, which is 1. 2 times 1 is 2. The next one, 2 times 3 squared. 3 squared is, or excuse me, that should be a 2. 2 squared is 4. 4 times 2 is 8. And the last one, 2 times 3 squared. 3 squared is 9. 2 times 9 is 18. So when I solve this, I get 1 and 2, 2 and 8, which would be about here, and 3 and 18, which would be about here.
2:36-second load, please walk out to your bus.
Say, sorry guys, it's not letting me draw on my thing here. Hang on. So it would be up high, we know that. And as you can see, it's not going to make a linear function. If we graphed our second problem, again, I'm going to make a table of values. Again, I'm going to use 1, 2, and 3. So I do 1 plus 2, which is 3, 2 plus 2, which is 4, and 3 plus 2, which is 5. If we plot those points, I would get 1, 3, 2, 4, and 3, 5, which as you can tell from that line is linear.